Welcome back again. So we're continuing to learn about Vsepr theory, and where we're at now is how do we use that information and the various shapes that could be possible for a covalent molecule. How do we apply that to a substance and figure out what shape it has? The reason why we're learning about this is because the shapes of molecules, as well as the polarity, which we've learned about, influence how substances react with each other. So as we move forward in class, you'll see that we'll do some experiments that will hopefully help demonstrate this, as well as just learning about the theory. So for right now, we're going to apply what we've learned about Vsepr theory, valence shell electron pair repulsion theory, or Vsepr for short, James Bond movie. So how do we use that to figure out molecular shapes or molecular geometry? So in your notes, you actually have step-by-step instructions on how to do this, and then you have a nice table that helps you figure out, once you've gone through the steps and you've laid out the number of bonded pairs and lone pairs and you've figured all that out, how do you know which shape it is? I'm going to go through that fairly quickly, but I also need you to understand that the explanation for it is important, and you'll be expected to show that you know that. So as well as recognizing the shapes, it's really important that you show that you know how we got there in the first place. So, step one. So the way that we figure this out, first of all, we're going to sketch the Lewis dot diagram. It might be that you could actually go straight to the line diagram if you wanted, but it's a good idea to start simple, right? So H2S, hydrogen sulfide. So I know that sulfur is in group 6. So 6 electrons in its valence shell. Hydrogen's in group 1, 1 electron in its valence shell. Alright, so sulfur now has 2, 4, 6, 8 electrons around it, more stable arrangement. Hydrogen's got 2 each. So then, what I'm going to do is change this diagram slightly so it looks more like this. So remember, the line represents a covalent bond or a bonded pair of electrons. You sometimes see lone pairs represented as a dash, but just remember that dots would be fine. This is maybe less work, I don't know, but just you sometimes see this and you'll sometimes see this, so just be aware of that. Right, so you've got your bonded pairs and lone pairs, and now what? So what we're going to actually do now is refer to the table that are in your notes. It says something about electron areas, and that's just maybe a complicated way of saying something very simple, which is where the electrons are, and the electrons are here, here, and here, so there's 4 places where they are. You've got 2 pairs of lone pairs, 2 pairs of bonded pairs. So if your molecule has that number of lone pairs and bonded pairs, then it's going to have the bent shape. So this would be 104.5 degrees for a bond angle. So the big thing that you need to remember is why does it make that shape? Why, for example, doesn't it make that shape? So as we've tried to get across in a couple of times now, the lone pair and lone pair repulsion is the largest, it's the most repulsion. So these two are going to push these 2 bonded pairs down. The amount of repulsion between these is less. So these push these 2 bonds closer together and bring down that angle. If you can imagine if we replace the lone pairs with 2 bonds, actually this would look more like a tetrahedral shape. So if you're seeing a trend in the numbers, that's a good thing, because 109.5 is the true tetrahedral bond angle. If that gets reduced because of this level of repulsion, then that number is going to go down because the bond angle is decreased. So why is that? Again, this is a little recap from a previous video, but The lone pairs are actually closer to the nuclei of the sulfur than the bonded pairs are. So the reason for that is because that even though sulfur is slightly more electronegative than the hydrogen, it's pulling the electrons a little bit that way. Hydrogen's also pulling back. So the electrons are closer, these bonded electrons are closer to the sulfur nuclei than the hydrogen, but the hydrogen is pulling back a little bit, okay, but just not quite as much. So these electrons in these bonded pairs would be slightly further away than these. So yeah, that's it. That's how you predict a shape. So I'll go through another example. I'll pause the video, go through another example, and then we'll see where we are.